Data, great search brought to you by DigiKey and Adafruit. Every single week, Lady Ada user power of engineering to help you. Yes, you find the things you need on digikey.com. Lady Ada, what is this great search of the week this week?
Okay, so this week, go to the computer. I'm working on this design to let me connect a solar panel to a charger that has solar input and will charge a light-poly battery. And so what I've done on other boards, like the BQ2474, right? This has a solar panel connects in, and then it charges a big battery, is I have two big diodes, because you always need a diode when you have a solar panel, because you don't want voltages to go back in, you want voltage and current to only go forward. And for most cases, a Schottky diode works fairly well, especially if you have, current of about 200 milliamps or so. Your forward voltage will be, 0.3 volts. It's, 0.06. It's like less than a tenth of a watt, maybe like a 0.2 watts of power lost to the diode forward drop. And I was designing this board, and then, as I'm working on more solar stuff, I'm actually getting into projects where the voltage in is getting, fairly high, like 10, 12, maybe 24 volt panels, like large panels are available and possible. And the amount of drop I'm willing to put up with is minimal, because if I have like a 24 volt panel, right, and it's a 20 watt panel, it's going to give me 1 ampere out. That drop, it's like I don't want to drop as much. If I have a 6 volt panel with 1 amp and I'm drawing the max current, I'm losing half a watt of power over the diode. I don't want to lose 10% of my power. And if I want to make like a higher quality product, I want to have something with a lower voltage drop. And so, for some of the stuff I've done so far, again, it's a low cost thing. Maybe it's okay to lose a little bit of power, but I want to have, as I'm doing more solar stuff, I'm like, I want to find a better solution instead of just using a Schottky diode, even though, works perfectly. And so one option is to use what's called an ideal diode. An ideal diode, you can look on educational electronic learning sites about it. You basically take two FETs together, you have a little controller, and it turns into a ultra low dropout ideal diode where current only goes one way. There's only forward voltage in, and you can also enable and disable it because it's like an active ideal diode. We have one in the shop already, and it's I think 5.5. It's 2.5 amps. It's like a good amount of current, but it's only 5 volts maximum input. It's meant for USB batteries, small electronic, power supplies. It's not meant for something like a solar panel, which, like I said, can be into the 24 volts plus range. And so, as I'm working on some more solar stuff, what I want to do is I want to find an ideal diode, especially one that's low cost. I want it to be on par with a Schottky diode, which is like 10, 15, 20 cents. I want it to be simple, ideally ideal, but also not too big, because I want to fit it on small boards. I don't want something with gigantic FETs. Can handle at least an amp or two of current and can handle at least 12 volts. And so I thought I would check out DigiKey to see if I can find a good alternative to this ideal diode I've got, which can't do higher voltages. So I actually just typed in ideal diode. And wow, there's a whole category, which is awesome. So going to the ideal diodes, going to this category, has about 600 options, which is good. And you can see some of these are, expensive. Some of them are not. They're it seems like about $1 or $2 a piece. Some of them are source selectors. A lot of them are or ideal diode or inputs. I don't need that. I just need one in, one out. So let's do what we normally do, which is check only for in stock or normally stocking. I don't want to look at marketplace items for now. I want only surface mount. I want active. And then again, my choice is for, there's internal switches. I won't select that yet, although I do kind of want internal switches only. I'm going to check the voltage supply because this is the thing that was restricting me before. And I'm going to make sure that I can do, well, actually, what's interesting is I want something that can go up to 12 volts. So I want to ignore these, but I also need it to be able to handle under 5 volts. Like 4 volts is actually the lowest that the solar panels I'm using might go to. So I'm going to ignore the ones that can't go above 12. So I'll pick these up. But once I get to, and that's 3.5 to whatever, I think I'll pick up these 4-volt pluses, but I think I'm going to drop any of the other ones because I think, well, maybe I'll do like 4.5. But definitely 5 is too high. And then some of these are like 40 volts max, 42 volt max, 50. So there's a lot of option clicking. But I think I picked up all the ones that I wanted. Let's see. Right, so then we've got, a couple options here. Some of these are controllers. So in this case, like I said, they're expecting that you will have the external diodes and then you get to pick how much current you want to handle. They still have a voltage limit because they have to be able to run from that voltage. I'm going to be picky again because I want it to be compact enough to fit on like a Featherwing or other board. So I'm going to say internal switches only. And then I don't really care, what, as long as the price is reasonable. Okay, so let's see what we got. Okay, got a lot of options, so that's kind of good. A lot of these say, the ideal diode path, 60 volts, which is sweet, $3.60, a little bit expensive. A lot of these have N channels. Some of these can be O-ring controllers, and what that means is you can have multiple of them together and tie the outputs, and they're fine with it. They won't freak out. Let's search for if I'm looking for 500 at a time. And then, we covered, I think, tariffs on the previous week. Check the price post-tariff. But it looks like there's 2 good options here, both very compact. One is the LM73100, and that one can do, they both have internal switches. This one's actually a little nicer. This one, it's not bad, but it does max out at 12. And so if I wanted to use it with higher voltages, because sometimes solar panels go a little high, so like a 12-volt panel will actually float at like 15 to 16 volts. So I actually kind of think I'm going to go with this one. I like, it's kind of got a weird, funky package here. But 5 amp, which is great, up to 23 volts also, looking good. It's a funky package with lots in stock. And the price is, like I said, it's on par when you get into the real quantity with a Schottky diode. It's twice the price, but you get so much better performance that I think it's definitely worth the upgrade. So I'm going to have to, hopefully, do they have a downloadable? Oh yeah, cool. They have a model. I don't want to draw out this. So don't forget, if they have models, you can download it in EagleCAD or Fusion or OrCAD or whatever Altium, your favorite. But it looks like they've got a couple footprints available for this kind of funky, looks like something you pick up in like Breath of the Wild or some other Nintendo game. It's like a special like energy concentrator. But yeah, ideal diode. Not too surprising. Usually they have for the input and output, they're going to have like really big chunky pieces of silicon for that. Not the drain, it would be the back of the diode, right? Because that's where the current's going to pass. And yeah, so I'm going to pick up some of these. I think what I might do is I might make this into a breakout to start because I think this would be actually kind of useful. And maybe I'll even make one that's a good, twofer. One thing that's funky is, there's a lot of like extra components that you don't need to have, but you can add to, because they're like, well, it costs us nothing to add like lockout voltages and stuff. So I don't necessarily need these, but you can configure them. And then of course the enable pin, which is kind of nice, is basically, on-off switch. So you can like very quickly turn turn on and off like the diode. So it's not only is a diode, but it's also like a switchable diode. Anyways, so I like this part. LM73100. So you'll probably see this in a breakout board soon at Adafruit Shop.
And that's the great search of the week this week.
Where